Hello Math 1093, this is Dr. P with A Common Language. In this video we're going to solve the equation 2 to the x equals 7 to the 2 minus x. Now just as a refresher, we have worked on solving exponential equations before. So this is what we did before. An example of what we did before would have been something like an equation that 2 to the x equals 2 to the, 9 minus 2x, which we would have solved by just saying, well, the base is the same. So if those are going to give us the same value, those exponents have to be the same. So we would have said x equals 9 minus 2x, and we would have said 3x equals 9, and therefore x equals 3. We would have been done. Okay, that's the type of equation we did before, but that is not the type of equation we are working with now. So let me just sort of bracket this off here. What's challenging here is that we have different bases, and that means that a lot of our old tricks are not going to work. So in this video I'm going to talk about 2 or 3 different techniques for solving this type of equation here where we have different exponential bases. The first technique I'm going to talk about is writing both exponentials in the same base. Writing both exponentials in the same base. So in other words, pick a common base or a common language for the two exponentials, and then get both exponentials into that base. So for this example, why don't we try writing 7 to the 2 minus x with base 2 instead. Okay, so the way that I'm going to approach this is I'm going to rewrite 7 as a power of 2. Okay, so if I want to write 7 as a power of 2, then what would that power of 2 need to be? So I'm going to call this something. I'm going to call it a, not x, because this is not the thing I'm solving for here. I'm going to say 2 to the a is 7. Well, what would a be then? To find a, I need to unpack this exponential by using the inverse function. The inverse function is a logarithm. So I'm going to take the log base 2 of 2 to the a equals log base 2 of 7. Okay, I know those two things are the same. And because here I have log base 2 of an exponential base 2, those two things cancel out. Those are inverse functions. So a is log base 2 of 7. Okay, so I could rewrite my equation as 2 to the x equals, and then let's see, well, this a is log base 2 of 7, so that means that 7 is equal to 2 to the log base 2 of 7. In retrospect, maybe I should have realized that a lot quicker, because if I want to write 7 as a power of 2, well, that's one way to do it. 2 and the logarithm base 2 cancel each other out. Anyway, I've got 2 to the x equals 2 to the log base 2 of 7 to the 2 minus x. And now I can simplify this equation on the right-hand side by using a property of exponents. If I have a power of a power, then that's the same as 2 to the log base 2 of 7 times 2 minus x. A power of a power is the same as taking the product of the exponents. And now I have an equation that is in the same base. The same base is 2. So now I can say, well, the exponents have to be exactly the same. So I can say that x equals log base 2 of 7 times 2 minus x. And now this is where things get a little bit dicey, and they're going to get dicey no matter which technique I use. But I'm going to need to multiply this out, distribute this log base 2 of 7. But realize that log base 2 of 7, let me rewrite that a little bit more clearly there. Log base 2 of 7 is just a number. So this can be manipulated like any other coefficient, like this is a 3, for example. It's not exactly a 3, it's a little bit less than 3. But it's the same principle. I'm going to get all my x terms together and then solve as though this were just a simple linear equation, because that's actually what it is. So I'm going to add log base 2 of 7 times x to both sides and get x plus log base 2 of 7 times x equals 2 log base 2 of 7. And then I can factor the x on the left and get x times 1 plus log base 2 of 7. And that's equal to 2 log base 2 of 7. So now x is equal to 2 log base 2 of 7 over 1 plus log base 2 of 7. And I could even calculate that, figure out what that is, Now for this, let's see, if I wanted to calculate this using just a good old-fashioned scientific calculator, I'd probably need to do a little bit more work. I'd probably need to rewrite this as 2 times natural log of 7 over natural log of 2, and then 1 plus natural log 7 over natural log 2. Here I'm using a change of base formula. And for my common base, I'm just picking e here. Natural log is log base e. Anyway, running that through a calculator, let's just see what we get here. 2 times natural log of 7 over natural log of 2, all over 1 plus natural log of 7 over natural log of 2. Sorry this takes so long. Looks like I get about 1.475. 1.475. So this is about 1.475. That's my value of x. Okay, and I could actually run that back through the original equation and check that these two values come out the same. Okay, now they're not going to come out exactly the same because I took a decimal approximation here, but I should get about the same thing. Okay, anyway, that was kind of laborious, but that's one approach for solving this equation. Now the other approach, I can't promise it's going to be any simpler or more straightforward. It's just we have to find some way to start with one of these, and it's more of a matter of finding a way to start that is natural for you, because what works in any of these techniques will work in pretty much any situation where we are working this type of equation. Okay, so let's rewrite the original equation. 2 to the x equals 7 to the 2 minus x. Okay, so here's technique number 2. Technique number 2 is just take a logarithm of both sides. Just do that straight away. And when I say take a logarithm, I really mean any logarithm. Take your favorite one. My favorite one is always the natural logarithm. I'll use the natural log. And then use properties of logs to simplify. So that's what I'm going to try doing here. Okay? So in this case, I'm going to apply the natural log to both sides and get natural log of 2 to the x equals natural log of 7 to the 2 minus x. And when I say use properties of logarithms, I mean in particular things like the fact that if I have a natural log of a power, then I can treat that exponent as a multiplier. So my next step is going to be to pull that out. That's x times natural log of 2 equals 2 minus x times natural log of 7. And at this point, you may see some commonality with what happened over here the first time I tried solving this equation, but this time I have natural logs. That's a little bit different. Okay, so let's distribute that right side out and get x times natural log of 2 equals 2 natural log of 7 minus x times natural log of 7. All right, now again, at this point we have to recognize this as a linear equation. It's gross looking, but it's just some number times x equals some number minus another number times x. That really is just a linear equation. So now I'm going to solve it by just moving this term, this one here, over to the left, getting all my x terms together just like I would anytime I had a linear equation with multiple x terms. So adding x times natural log of 7 both sides gives me x times natural log 2 plus x times natural log 7 equals 2 times natural log of 7. And then factoring that x gives me x times natural log 2 plus natural log 7 equals 2 times natural log of 7. And I could now divide by that constant to get x equals 2 natural log 7 over natural log 2 plus natural log 7. And let's see what that comes out to. I mean, I'm hoping it comes out to 1.475 because that's what I got earlier and I was solving the same equation. So we should probably be concerned if we don't get the same value. Okay, so running these numbers gives me, yes, I still get 1.475, even though it's in a totally different form. This is kind of weird. This does give me 1.475, same as before. Yay. Okay. Yeah, you'll notice that there are some differences between the exact form that I got here and the exact form that I got here. However, if I were to take this fraction here, the one I got on the first pass, and multiply both the numerator and the denominator by natural log of 2, I would actually algebraically get this very same thing here, which is kind of nice to see. Anyway, so those are two techniques for solving an exponential equation involving different bases. One technique is to try rewriting the exponential function, or sorry, the exponential equation in one base, like a base of 2. I could have chosen a base of 7. I just like 2 better. And the other technique is just start out by smacking this thing in the head with a natural log or your favorite base logarithm. You could have used a log base 2 here. Would have had the same result. Anyway, I'd be curious to know what technique or what approach seems more natural to you.